Good morning, ladies and gentlemen. We're about to open the window on what I think is one of the most wonderful professions in the world, and perhaps the oldest profession in the world. But I would like to start it by telling you that I'm expecting you to participate in the presentation, because only then are we going to get the maximum amount of good out of it. And I'd like to start with something that may seem a little ridiculous to you, but what I want to do is I want to define for you what I think a good teacher is. Doesn't mean I think I'm a good teacher, but I want to tell you something about teaching. I think a good teacher is someone who can tell you something and then you can do it. And if you can do that, then we say we're pretty good teachers. And the biggest group of teachers in the world are parents. And a parent typically will say to a child, "Now this morning I'm going to teach you how to tie your shoes." And they'll say, you take your shoestrings in your hand and you just tie them like that. And when you go to bed at night, you just pull them apart, right? And that's the way you learn to tie, or maybe that's the way you teach your children. Well, that's not quite everything that they say. They say when you tie your shoes in the morning, don't get these little things all tangled up in, because they'll never come apart, right? Unless you happen to be a metallurgy professor and it comes apart for you, right? Well, actually, the parent doesn't teach the child, the parent shows the child. And if you want to teach somebody something, what you have to do is to have a common language. Everybody has to speak the same terms, understand the same terms. And for instance, if I want to teach you how to tie your shoes, you have to know the names of a piece of rope, a piece of string. And so, for instance, every piece of string has two ends. They're called bitter ends. And if you put them together, the thing that's left over at the bottom is called a bight. And you need one other piece of information. Do you know there are only two kinds of knots in the world? Only two. Actually, if you're in the Boy Scouts, the Girl Scouts, and the Navy, it doesn't make any difference. This funny little knot's called a half hitch. And if you let go, one end comes apart pretty easily. And if you're in the Navy, they call this one a marlin hitch. But actually in the Boy Scouts or the Girl Scouts, they call this one an overhand knot. And it looks like that. And if you pull it tight, it's more difficult to pull apart. All knitting, weaving, macrame, everything that you do with strings or ropes is just some combination of those two knots. But now I can tell you how to tie your shoes. You get up in the morning, you take a bitter end in each hand, and then you make an overhand knot or a marlin hitch. And then you make a bight of each bitter end. And then you make an overhand knot with that bight. And when you're finished, your shoes are tied. When you go to bed at night, you pull them apart, and you always have to take this little overhand knot apart. So you see, if you know the words, if you understand the words and I understand the words, then we can communicate and understand. Well, we're stepping into this world called metallurgy, and the first thing we have to find out is what a metal is. Now, I hope that you will respond to this, because I've asked this question for many people, and I know about what the ratio of answers should be. So I want to ask you, do you happen to know what a metal is? Could anyone here tell me what a metal is? If you can now, just speak up.
I could volunteer and ask for a physicist's definition.
All right.
It's anything except hydrogen and helium.
All right. I might accept that one from an astrophysicist. But how about you? Do you know what a metal is?
From an engineering point of view, is that something that we can use that to construct buildings, build vessels.
Well, let me ask you this. Let's suppose you wanted to check, see if your child or someone's child knew what a piece of metal was. And out on the lawn there's a piece of metal, and you say, hey, why don't you get that piece of metal and bring it back? It's going to get caught in the lawnmower. Would you expect them to bring back a piece of wood? No. How do you tell from where you are looking way off there that that's a piece of metal? Anybody?
It's hard.
But you can't tell it's hard looking way over there in the grass.
Shiny.
Shiny. But you know, I'm going to take my wife dancing Saturday night. We're going to get her on the patio, and the moon's going to be shining those beautiful shiny eyes. Man, that ain't a metal, right? No. So what do you mean when you say shiny? How about it? Do you know what a metal is?
Metallic substance.
Just a metallic substance. Well, I don't want to belabor the point too much, but I want to...
Yes. It's something which fills far as electron orbitals go, it's not one shy of filling the p orbital. Or
What you're saying is it has a certain valence, perhaps, a
Yes.
certain electronic
Right around
construction? All right, but let me tell you something. You really don't know what a metal is. And there's a big group of people out there that don't know what a metal is, and we have a name for that group of people. Do you know what we call them? Metallurgists. And they don't know what a metal is. And so what they do is they establish a definition. And here's a metallurgical definition of what a metal is. They say a metal is an element, right? That's the first thing it has to be. A metal is an element that has metallic properties. Now, if we did that in an English class, they'd knock us down for that. You can't put the word in the definition, but we do. And then we go to work and we look at the definitions. Well, actually, if we looked at the periodic table, what we would see is, we'd see that we have your friend hydrogen sitting way over on this one side, and some people say that's a perfectly good metal. But we look at it and we say across the periodic table, everything on this side will be a metal and everything on that side will be a non-metal. Well, that's a fairly good definition from the standpoint of the periodic table and what the elements are. But let's see if we can get to those metallic properties. Can you tell me a metallic property now?
Ductility.
Ductility, perfectly good. Just like chewing gum, right? Does that make chewing gum a metal? No, because chewing gum's not an element, right, sir?
Conductivity.
Like graphite?
No.
No. But that's certainly a metallic property, isn't it?
Graphite isn't very ductile, so if you eliminate graphite.
Well, now you're putting it together with him, right? How about another property? Come on. Did you ever build a kite?
Yeah, high density.
Sure. They're heavy, right? All metals are heavy. True? No? What's not heavy? Aluminum. How much do you think a cubic foot of aluminum would weigh? Guess. Just hurry up. Huh?
250 pounds.
250 pounds. 10 pounds. Well, actually, well, this is what answers that we normally get, because most people think aluminum is very, very light. Actually, a cubic foot of aluminum weighs about 170 pounds, something like that. So metals are heavy. Now, of course, some metals are light enough to float on water, but most of them are heavy. Another property now?
Well, both electrical and heat conductivity.
Yes, very good conductors of both electricity and thermal energy. Yes.
Maintains luster, polishability.
Stay shiny. And do you know, we have trouble with that word. We recognize, I hold up a piece of metal and I say, is this a piece of metal? You say yes, because it looks like a metal, right? Looks like a cow, you call it a cow. Looks like a piece of metal, you say it's a piece of metal. But what do we really mean? And so we have a special description for it. You know what we call that? Metallic luster. And there we go, putting a word in the definition again, and we don't know any other way to do that. But it does have this metallic sheen. How about another property? How about this young lady? Suppose we went up on the roof and I got permission to hang you over the side of the roof with a little thread. Would you rather it be made out of cotton or made out of metal?
Metal.
Why?
Strong.
Strong. Metals are strong, right? And that's what the gentleman said earlier. We want to use them in design. Well, the funny part about it is that if we got a bunch of metallurgists in a room, a bunch of people that knew all about this field, and you say, okay, metals are going to be these elements that have metallic properties. Now what we have to do is we have to come to grips with how many properties does this element have to have before we're going to say it is a material that we will call a metal. How many metallic properties does it have to have? 3, ductility, hardness, strength, or does it have to be 5 or 7? And so the metallurgist, so nobody gets together on exactly how many metallic properties it has to have to be called a metal. So we have this little area of confusion of exactly what a metal is. But that is the way we set up the definition. Well, now let me ask you this question. How about a property of a metal that everybody would recognize almost off the bat, and probably improperly so, that if you just shut your eyes and touched it, you would know it's a metal. How about that? Well, that's a conductivity. That's hard. Well, you can tell that a little bit by touching it, but there's something else you know. It's solid, right? So generally, at room temperature, most of the metals we know are solid materials. Well, let me see if I can tell you something about a metal now that you may or may not know, but I think it's the most fascinating part about this whole field, and we're going to sort of set it up as a focal point through which we're going to work this week. All metallic materials are crystalline. It's composed of metal crystals. Now, would you hold your hand up if you already know that? Does everybody here know that metallic materials are crystalline? Is there anybody here that didn't know that? Okay.
What about mercury?
Well, at room temperature, it's going to be a liquid, right?
But when it solidifies, is it
It's crystalline. Yes, it's going to be crystalline. And when it's solid, in the solid state, its metals are going to be crystalline. So, now that I've told you this, I hope you'll believe it, but all metallic materials are crystalline. Then I have a question to ask you. Have you ever held any metal crystals in your hand? How about you? Anybody else? Have you ever had a handful of metal crystals? And but look, I just told you that all solid metals are crystalline. And anytime you have a solid metal in your hand, you got crystals in your hand. Now the reason you don't recognize this is, if you were to take a table knife, a stainless steel table knife, and you looked at it, you'd find out it has about 25,000 crystals in it. That means the crystal size is going to be very, very tiny. And you'd have to look in a microscope to see them. Not only that, you'd have to prepare it so you could see it. Like if you want to see a cell of biological tissue, you may have to stain it to look at it in a microscope. So we have to polish the materials, etch the materials, and then look at them in high magnification so that we can see what is crystalline about the material.